Hi everyone, welcome to a new episode of I Square. Today we are going to discuss about decimal expansion of rational numbers. In the previous classes we learnt about Euclid's lemma, Euclid's division algorithm, then we learnt about HCF and LCM of two numbers, and finally we learnt about irrational numbers, and also we learnt how we can prove a number to be irrational, that is how we can prove root 2 is irrational or root 5 is irrational, or now we are in a position to prove any number is irrational just by using certain techniques, right? If you haven't seen the previous videos, the link is given in the description, please go through it. Now we shall move to the decimal expansion of rational numbers. We know that any rational number can be expressed in the form p by q, right? Where a condition is there, q must not equal to 0, right? If q equal to 0, this is not defined, okay? So any rational number has the form p by q, right? Okay, now we are going to check about the speciality of these forms or the properties of any rational number when we express it in the form of p by q. Okay, we know that any rational number has two properties. When we divide this p by q, either it can be a terminating number or it can be a non-terminating repeating number. Okay, if it is non-terminating, non-repeating number, then it will be termed as an irrational number. So a rational number has two possibilities, which are, one is terminating and the next one is non-terminating repeating. So it will not terminate, but the numbers will repeat after a finite stage. Such two possibilities exist for any rational number p by q. So any rational number p by q can easily be represented like this. If p by q is a rational number, then it has two possibilities. One is terminating or it can non-terminating repeating. Okay, now we shall check when it will terminate and when it will non-terminate. So let us move into some examples. Here we have three examples. The first one is 0.375, the next one 0.104, and the third one is 0.0875. Now we shall check the properties of these numbers. Okay, easily we can observe that these three numbers are nothing but terminating decimal expansion of some rational number, right? 0.375 is terminated after 3 decimal places, whereas 0.104 also terminated after 3 decimal places, and 0.0875 terminated after 4 decimal places. Okay, now we shall check how we can easily confirm that such a rational number will terminate, or what is the speciality of these three numbers. First of all, let us consider 0.375. Now we are going to transform this decimal point to 3 places to right. Okay, that is, we are going to transform this point to here, so that this number will be equal to 375. So in order to transform this point to here, we have to multiply it by 1000, since we have to change the point to 3 places. We have to multiply it by 1000. It is not possible to multiply alone. So in order to change an equal transformation, we have to divide simultaneously by 1000. So it will be equal to 0.375 into 1000 divided by 1000. See, 1000 and 1000 cancels and there is no change for the number. So it is a valid relation. Now 0.375 into 1000, it will be equal to 375, since when we multiply this number by 1000, the decimal place will change 3 places to the right, right? So 375 divided by 1000. Now we have 1000 is nothing but 10 cube. Of course 10 square is 100, 10 cube is 1000. So we have 375 divided by 10 cube. Now we are going to make a small transformation. We know that 10 cube is equal to, 10 is nothing but 2 into 5. So we have 10 cube is equal to 2 into 5 the whole cube, that is 2 cube into 5 cube. Since AB the whole cube equal to A cube into B cube, it is always a valid relation. AB the whole raised to 4 equal to A raised to 4 into B raised to 4. AB the whole raised to 5 is equal to A raised to 5 into B raised to 5, and so on. So 10 cube is nothing but 2 cube into 5 cube. Therefore we have 375 divided by 2 cube into 5 cube. Okay. Now we can cancel the common terms. In order to cancel the common terms, we have to reduce 375 to its prime factors. We know that how to reduce a number to its prime factors. It is enough to divide the number by the primes which are factors of those numbers. So we shall reduce 375 into its prime factors so that it is possible to cancel the common terms. So we have 375 equal to nothing but 5 cube into 3, right? Divided by 2 cube into 5 cube. And here the 5 cube cancels and the result will be 3 by 2 cube, right? What we have done, first of all we transformed 0.375 into a form like this, then we divided it by 1000, and 1000 is nothing but 10 cube. 10 cube can be again be split as 2 cube into 5 cube, and the result will be like this. Therefore 0.375 is nothing but 3 by 2 cube. Similarly we can transform 0.104. 0.104 is equal to 104 divided by 1000 equal to 104 divided by 10 cube equal to 104 divided by 2 cube into 5 cube, right? It is equal to, now we have to cancel the common terms. In order to cancel the common terms, we have to find the prime number factorization of 104. So 104 is nothing but 2 cube into 13. So we have 2 cube into 13 divided by 2 cube into 5 cube. Therefore 2 cube and 2 cube cancels and it will result in 13 divided by 5 cube. So 0.375 is nothing but 3 by 2 cube. 0.104 is nothing but 13 by 5 cube. Now we shall transform 0.0875 similarly. So when we transformed 0.0875 like this, we have to multiply it by 10,000 since we have 4 decimal places to the left. Similarly, we have to divide simultaneously, we have to divide it by 10,000 so that the relation will still be valid. Then we have, when we multiply it by 10,000, 4 decimal places will be transformed to the right. Hence we get 875 by 10,000. 10,000 is nothing but 10 raised to 4. 10 raised to 4, 10 is equal to 2 into 5. So 10 raised to 4 is equal to 2 into 5 the whole raised to 4. So 875 equal to 2 raised to 4 into 5 raised to 4. Now 875 has the prime factorization 7 into 5 cube. You can easily find this by dividing 875 by its prime factors like before. So we get 875 is equal to 7 into 5 cube. Now we can cancel 5 cube and 5 raised to 4. Since here is 5 cube, we can cancel one 5 cube from here and the remaining will be a 5. So when we cancel, note that when we cancel 5 cube and 5 raised to 4, it will look like this. 5 cube divided by, this is 5 raised to 4, 5 into 5 cube. Since 5 raised to 4 can be written as 5 into 5 cube, and when it will cancel, we get 1 by 5 as the result. So there is a 1 by 5. So 7 divided by 2 raised to 4 into 5 will be the answer. Is it clear? Now look into our examples. When 0.375 transformed into P by Q form, we get 3 by 2 cube. When 0.104 transformed into P by Q form, we get 13 by 5 cube. When 0.0875 transformed into P by Q form, we get 7 divided by 2 raised to 4 into 5. Clear? Note that these three numbers have terminating decimal expansion. Here only 3 digits to the right of point, and here only 3 digits to the right of the decimal place, and here only 4 digits. So three of these numbers, all the three numbers have terminating decimal expansion, and when we transformed these three numbers into its P by Q form, we can see that always in the denominator we have a 2 and a 5. Maybe 5 absent or 2 absent, maybe both 2 and 5 together present. Anyway, we have 2 and 5 in the denominator. That is, whenever a decimal number have a terminating decimal expansion, when it transformed into P by Q form, we have the denominator Q in the form of 2 raised to m into 5 raised to n. That is, see, each and every time when we transformed a terminating decimal number to P by Q form, in the denominator we have either 5 raised to something or 2 raised to something or 2 raised to something into 5 raised to something, right? So we can generalize this result. So we can generalize the result as follows. Let x be a rational number whose decimal expansion terminates. In the previous example, we considered 0.375, 0.104 and 0.0875. That is, we considered 0.375, 0.104 and 0.0875, right? Each of the number have a terminating decimal expansion. So whenever x be a rational number whose decimal expansion terminates, then x equal to P by Q. Of course, we represented each of the numbers in the form of P by Q, and Q is of the form, that is, the denominator Q is of the form 2 raised to m into 5 raised to n. That is, whenever the denominator has only 2 power or 5 power or both 2 raised to m into 5 raised to n form, then we can say that the decimal expansion of that number will definitely terminates. Clear? So in order to check whether the decimal expansion of a number terminate or not, it is enough to check that the denominator of the number is of the form 2 raised to n or 5 raised to m. Or in other words, we can say that if we are given with a terminating decimal expansion of a number, suppose we are given with numbers like this which has terminating decimal expansion, then we can always assure that, or we can say confidently that this number, the decimal expansion of these numbers will have a rational expansion of the form P by Q, where the denominator Q has the form 2 raised to m into 5 raised to n. Is it clear? Now we shall check the converse, that is, whenever a rational number has a denominator of the form 2 raised to m into 5 raised to n, whether it will terminate or not. Now we have proved that whenever a terminating number is given or terminating decimal expansion is given, it will definitely have a P by Q form where Q has the form 2 raised to m into 5 raised to n. Now we are given with a rational number whose denominator is of the form 2 raised to m into 5 raised to n. Now, and we are going to prove that it will have a terminating decimal expansion. So now we are given with 3 examples. First one 3 by 8, next one 13 by 125 and the third one 7 by 80. We are going to find the decimal expansion of these numbers. Okay. First one 3 by 8. We are not going to divide it, but we are going to apply a small trick to find whether the number terminates or not. Let's check how we can do that. We know that 8 is nothing but 2 cube, right? See, the denominator is of the with the power 2 of a power, right? The denominator is of the form 2 raised to m. Let it be there. And we know that 3 by 8 can be represented as 3 by 2 cube. Now we are going to apply a small trick. We have 2 cube already. Now we are going to make this in the form of a 10 cube. For that we have 2 cube, a 5 cube is absent, right? So we are going to divide and multiply with the 5 cube at a simultaneously. See, when we divided and multiplied the same number with the same number, there will not have a change, since 5 cube and 5 cube cancels and the result will remain the same. So it will not cause a change in this transformation, right? So we have multiplied and divided this number with the 5 cube. Then we have this number will be 3 into 5 cube divided by 2 cube into 5 cube is equal to 10 cube. 2 into 5 equal to 10. So 2 cube into 5 cube will be equal to 10 cube. It is equal to 3 into 5 cube equal to 125 divided by 1000. It is equal to 375 divided by 1000. It is equal to, so when we divide a number by 1000, it is enough to put 3 decimal places to the left and put a point here. So we have 3 decimal places to the left and put a point here to get the answer. So the answer is nothing but 0.375. Now we shall look into the next problem. 13 by 125. We know that the prime number factorization of 125 is nothing but 5 cube. Therefore it will be equal to 13 by 5 cube. Now we are going to multiply and divide this number with 2 cube to make it 10 cube, right? You got the trick, right? If it is here 5 cube, then we have to multiply the number with 2 cube. If here is 2 cube, then we have to multiply the entire number with 5 cube. So we are going to multiply and divide the entire number with 2 cube. So it will be equal to 13 into 8 divided by 5 cube into 2 cube will be again equal to 10 cube. So we have 104 divided by 1000, since 10 cube equal to 1000, and it will be equal to 0.104 by the similar process. Clear? Now we shall look into the third example. 7 by 80. 7 by 80. It is equal to, the prime number factorization of 80 is equal to, okay, you can find it out. And when we got the prime number factorization of 80, it is enough to multiply the numerator and denominator with a number so that the denominator will be the power of 10. Okay, then we can find the answer just like this. Coming to the third problem, 7 by 80. We have 80 is equal to, sorry, that's also a cut. Coming to the third problem, 7 by 80, we have 7 by 80 is equal to nothing but 2 raised to 4 into 5. It is equal to, now here we have 2 raised to 4. Also we have a 5. So in order to make this 10 raised to 4, it is enough to multiply the numerator and denominator by 5 cube. Since we already have a 5, so we need 3 more 5s. So to make it 5 raised to 4, so we are going to multiply the numerator and denominator with 5 cube. So that we got 5 raised to 4 here. Since we already have a 5, it is only needed to multiply with 5 cube. Okay. Therefore we have 7 into 5 cube divided by 2 raised to 4 into 5 raised to 4. It is equal to what? 7 into 5 cube divided by, this is nothing but 10 raised to 4. Okay. Now 7 into 5 cube is nothing but 5 cube equal to 125. 7 into 125 divided by 10 raised to 4. Now 7 into 125 equal to 875. It is equal to 875 divided by 10,000. So we can put 4 decimal places to the left to get the answer 0.0875. So in all the 3 examples, we can see that whenever we are given with a fraction, of the form p by q, we can convert it to the form of a terminating decimal number, right? Why? Because the denominator is of the form 2 cube or 5 cube or 2 raised to 4 into 5. That is, in general, whenever the denominator is of the form 2 raised to m into 5 raised to n, the decimal expansion will be a terminating decimal number. Okay, so we can write this also as a result. And the result can be stated like this. Let x equal to p by q be a rational number such that q is equal to 2 raised to m into 5 raised to n. Then x has a terminating decimal expansion. In the previous examples, we are provided with 3 rational numbers, say 3 by 8 and so on. And when we converted it into decimal forms, we saw that all the 3 decimal numbers are terminating decimal numbers. Why? Because the denominator q is of the form 2 raised to m into 5 raised to n. Hence, we can conclude that result as whenever a number has a terminating decimal expansion. Whenever a number has a terminating decimal expansion, the denominator will be of the form 2 raised to m into 5 raised to n, as well as whenever a number is of the form p by q, where q is equal to 2 raised to m into 5 raised to n, its decimal expansion will terminate. That is, a decimal number or a number have a terminating decimal expansion. A rational number have a terminating decimal expansion if and only if its denominator is of the form 2 raised to m into 5 raised to n. Always remember that a rational number has a terminating decimal expansion if and only if its denominator is of the form 2 raised to m into 5 raised to n. So I hope all of you understood the concept very well, and the concept of rational numbers, when it will terminate, and how we can say that it is a terminating decimal number or not. I hope you all got a clear understanding about that topic. If you have any doubts, please comment in the comment section.